have scientists now found the real answers to how our solar system was formed. In the Kuiper belt, NASA discovered mysterious objects. Are these oldest objects in the solar system really the first pieces of the puzzle to finally explain our own existence? The answers to these questions will always bring us closer to understanding the fundamental processes that led to the birth of the planets and the origin of life. The question remains, what else lies hidden in the unexplored vastness of the Kuiper belt? The Kuiper belt is one of the last unexplored regions of the solar system. Only one region is even more mysterious, the Oort cloud, which is located around 7.5 trillion to 30 trillion kilometers outside the heliosphere. The Kuiper belt, which is around 4.5 billion kilometers wide, was discovered in 1992 by astronomers David Jurett and Jane Law. This discovery marked a turning point in our understanding of the entire solar system. Jurett and Law used the 2.24-meter telescope at the Mauna Kea Observatory in Hawaii to search for evidence of objects beyond the orbit of Neptune. Their persistence was rewarded when they discovered the first true Kuiper belt object, 157601992 QB1. This discovery opened a whole new chapter in astronomy and confirmed the theory that a region full of smaller bodies exists beyond the known planets. Scientists refer to these bodies as KBOs or Kuiper belt objects. Since their discovery in the 1990s, scientists have suspected a colorful hodgepodge of objects within this belt, most of which are direct relics of the first moments of the star system's formation. Imagine it like this: in the beginning, there was probably a dense collection of dust and gas, which began to vibrate and then rotated faster and faster until the center of the cloud heated up and condensed to such an extent that a star was born. After the formation of the star, our Sun, the remaining gases and dust began to clump together due to gravity, leading to the formation of planetesimals. These protoplanets later formed into all the large planets we know today. Others formed into moons, and still others remained shapeless lumps that attached themselves to planets as less round satellites or traveled freely through the solar system as asteroids. All the materials that did not form larger bodies accumulated in regions such as the Kuiper belt, the Oort cloud, or the asteroid belt between Mars and Jupiter. These objects have remained largely unchanged for 4.6 billion years. Unlike our Earth, they have not undergone major upheavals and changes. Therefore, KBOs and similar objects offer us unique insights into the chemical composition and physical conditions of the early solar system. More than 1 trillion objects are spread across the 4.5 billion kilometers of the Kuiper belt. The objects in this region range in size from tiny grains of dust, pebbles, and stones the size of a soccer ball to boulders the size of a family home. The Kuiper belt is probably also home to a number of asteroids and possibly comets, with the Oort cloud being the actual home of comets. The Kuiper belt is home to dwarf planets, including Pluto. The objects of the Kuiper belt probably accumulated here immediately after their formation. Regions such as the Kuiper belt and the asteroid belt were probably formed by gravitationally favorable fields, which favored the accumulation of objects in these areas. Today, we can be glad that all these objects are reasonably securely bound in the solar system. If they were flying around wildly, they would all be a potential threat to our planet. There are 1 trillion objects in the Kuiper belt alone and another 1.1 million in the asteroid belt. How many objects have accumulated in the Oort cloud is still pure speculation, but there are probably trillions more. The other planets could only come to rest in the course of the development of the solar system and form life like our home because these objects were securely bound. While we know quite well how the large planets such as Earth, Jupiter, and Saturn formed and changed over time, it is still largely unknown how and why the dwarf planets evolved. For almost a century, we only knew about Pluto and included it in our fixed 9 major planets of the solar system. Then came the change with the discovery of the Kuiper belt and fascinating objects such as Eris, Makemake, and Haumea. Eris was discovered in 2005 and sparked a debate about the definition of a planet, ultimately leading to Pluto losing its status as the 9th planet. Eris is about the same size as Pluto and more massive. It orbits the Sun at a distance of about 68 to 97 astronomical units and takes an incredible 557 years to do so. Eris's surface is exceptionally bright, indicating the presence of frozen methane. Makemake, discovered in 2005 and named after the creator god of Easter Island mythology, is another large KBO. At a distance of around $45.80, Makemake takes only around 310 years to orbit the Sun. This dwarf planet is also remarkably bright, indicating a largely uniform surface. Haumea, discovered in 2004 and named after the Hawaiian goddess of fertility and childbirth, is known for its unusually fast rotation, taking only about 4 hours for a complete revolution. This fast rotation makes Haumea look like a rugby ball. Haumea is located around $43 from the Sun and takes around 285 years to complete one orbit. Haumea has 2 moons and is the only known object in the Kuiper belt with a ring system. In addition to these 3 largest and best-known dwarf planets, there are many other minor planets in the Kuiper belt. Sedna, for example, is an enigmatic object whose orbit takes it far beyond the usual boundaries of the Kuiper belt. Quaoar, about half the size of Pluto, shows signs of cryovolcanic activity which researchers did not expect in these remote areas of the solar system. The small and sometimes quite misshapen dwarf and minor planets show such diversity and complexity that scientists suspect they form a world of their own and possibly share an exciting common history. We don't know how many more objects there are in the Kuiper belt. There could be 100 or even more. This was one reason researchers had to draw a line on which planets are now part of the official planetary system. In 2006, the International Astronomical Union created the category of trans-Neptunian objects or dwarf planets. Pluto did not make it into the League of Real Planets because its orbit is not fully cleared, meaning it does not have gravitational dominance in its orbit around the Sun. Pluto's orbit is crossed by other objects in the Kuiper belt, and it shares its orbit with other objects. Mysterious accumulations of water in the Kuiper belt suggest that the cradle of life could lie there. Many objects in the Kuiper belt are rich in water ice, which could contain pre-solar molecules older than the Sun itself, providing clues to the chemical processes that led to the formation of water and organic material in the early solar system. By studying the composition and distribution of these icy bodies, scientists hope to understand the earliest sources of water in our cosmic home and unravel the mysteries that influence Earth's habitable zone and the possibility of life in the universe. We do not yet know how water and life came to our planet, but asteroids and comets, which transported the most organic substances, may hold the key. Comets consist of a mixture of dust, ice, and rock. They clumped together in the early days of the solar system when our star was still very young, and the planets had only just begun to develop. It remains one of the greatest mysteries of our existence, which mechanisms favor the formation of life and where life organically came from. From 157601992 QB1 to Arakoth, the incredible variety of objects traveling in the broad band at the edge of the solar system could be researched for another 1,000 years, and scientists would always find new objects and surprises. The Kuiper belt, with all its diversity, would not even be a thin thread of hair within the cosmos. It would be nothing. We can only stand in awe and respect before the dimensions and splendor of the universe. The first discovered Kuiper belt object, 157601992 QB1 or 15760 Albion, is a planetoid with an average diameter of 168 kilometers. In the early days of the solar system, this object could have become a planet or combined with other objects. It is still a mystery what processes lead to some chunks merging with others, while those like 15,760 Albion spend billions of years orbiting the Sun like unfinished small planets. Albion was discovered at its perihelion, its closest position to the Sun, in 1992. It is currently moving away from the Sun and was $41.30 or 6,178,392,000 kilometers away from our star in January 2018. Probably the strangest KBO is Arakoth, initially called Ultima Thule. Since NASA's New Horizons mission took a close look at the KBO, the name Arakoth, meaning sky in the language of the Powhatan and Algonquian Indians, has become established. This binary contact object consists of 2 originally separate bodies that gently came together. Its flat shape and relatively smooth surface contrast with the expected characteristics of collisions. If Arakoth was not formed by collisions, previously unknown processes of matter formation in the early solar system may have led to its unusual shape. If you love amazing videos, subscribe to this channel now.